It's it's after start time, so we may as well get started. My name's Chris Hewitt, and these days I spend my time looking at stock markets, basically, which is why it says quant analyst up there. For a long time, I was a DBA. Actually, my third job was for one of the first relational database ISVs, basically. And I was a very junior member of a development team building a relational database engine that's so embarrassing that I won't even mention its name, right? You know, they wrote the engine, I made the coffee, or actually I did the backup and restore stuff. And these days, I like to hang around with the SQL Azure guys. Actually, I do hang around with them a bit, so I know what they do. So I get to talk about federations, which is kind of a cool thing. Oh, I can use this little clicker here. And what we're going to talk about today is what SQL Azure Federations is, why you might want to use it, how it works. We're going to do some hands-on stuff and see how it works, and then talk about a couple of things that come out of using the CTP at least. So what are federations in SQL Azure? Basically, they're an implementation of sharding in SQL Azure. There are some new SQL commands and some new system views and tables that support, this is very sibilant, isn't it? That support sharding. And they make it easier to scale out and scale back in. Now with SQL Azure, you could always scale out. I mean, the whole point about SQL Azure is that it's almost infinitely scalable. But what Federations does is put support for the scaling into the engine and makes it easier to do. So who remembers a film, This Is Spinal Tap? That is the right name. Yeah. Show of hands. Who remembers This Is Spinal Tap? Okay. The trouble of getting old is that you're, the things you reference, like, it goes to 11, right? That's what the 11 is about. In that film, there's this famous scene where the guy's amplifier goes to 11. So, but yeah, those references stop working after a while. But SQL Azure basically scales very easily, and what Federations allows you to do is to do that scaling, is to control that scaling with commands that are implemented as part of the engine. So we can run with just a few nodes, and then we very quickly ramp up to having hundreds of nodes, lots of databases. It's not just databases that you get, so it's more than just simply database size. With every database, you also get CPU and memory, and you also get temp DB. So it's basically your entire data tier scales really easily, and you can scale it back as well. So it gives you commands that allow you to say, okay, we've been running with 20 databases, now I want to run with 200, and then tomorrow I want to run with 20 again. So yeah, it's just a nice picture of that. One of the reasons that we want to use this is because we want to build multi-tenancy systems. The project I worked on before my current project involved SQL Azure databases, so building SQL Azure databases where we had one tenant per database, so one end customer per database, and that works fine. But the problem with that is that we had to control we had to build code to control the provisioning of these databases, basically the code around that we had to, a classic, must turn off Skype. I'll leave it. Okay, there'll be a few things that pop up. Because this is, you don't need to know that. And the problem with that is that, we had hundreds of thousands of these customers. So we have, up to 100,000 SQL Azure databases, one tenant per database. We had to do that because of safety. Effectively, if you've only got one tenant per database, you can't give one customer's sensitive data to someone else. So, for safety purposes, we had one tenant per database, but some of these customers were very small. Some of them might only need, 50 meg of data storage. So, we would like to put many of these customers into a single database, and we can do that by writing lots of code and testing it really well. Because the one thing you don't want to do is show somebody else's data. With SQL Azure federations, you get T-SQL commands, a use federation command, that allow you to safely program against a single SQL Azure database with many tenants in it. And so the other thing where you have one tenant with many databases, we can also do that. I mean, it would be a different federation model, a little bit harder. So naturally it does multiple tenants per database, one tenant per database, and it could also be used to implement multiple databases per tenant. And why we want to do this? For web scale, all right, so if we need to be able to scale out hugely, now again, you can already do this with SQL Azure. You can already have hundreds of thousands of databases with SQL Azure. There are people that right now run many thousands of databases, but we can do this in a dynamic way and in a much easier way where we don't have to manage these databases. Because the problem when you have thousands of databases is how do you manage that? Actually, again, going back to the project that I worked on before this, that was the very reason why we chose to go with SQL Azure, was because we thought about it and we thought, okay, we need 100,000 databases out there in the cloud. And there are a few people who could there are a few services that could give us databases. And the reason that we chose SQL Azure was it was like, who can we trust to manage this? Who can manage hundreds of thousands of databases? And these other guys have got a few hundred, right? Okay. So SQL Azure scales, and federations allows us to do that using features of the engine. We already talked about why we might want multi-tenancy and why that's useful. And workload spikes. So say I have, the classic example is say I have a ticketing system where we have a load that comes on, just before a concert or something like that. They always use this example. You can have 100 databases and then you can go up for a day to 1,000 databases and then you can go back down to 100 again. Now, you can do this in SQL Azure, but you have to manage that yourself. With federations, you'll be able to basically do that automatically. Well, we have to issue some T-SQL commands, but that's not really very hard. Now, I use the term NoSQL probably cheekily in the description of this talk. How many people came here to talk about NoSQL, right? No? Come on, be whatever. All right. Because really, it's not NoSQL because, okay, the thing about NoSQL is that, one of the things is that we want to get throughput. And the problem is that SQL Server, that SQL databases, not just SQL Server, but other relational databases, their primary concern is with consistency. So you have locking and you have transactions and you have rollback and things like that. In order to implement that tends to slow you down. So when you're building huge applications, it causes a problem. The consistency becomes a problem, so you have to do trade-offs. So you trade off the consistency for something else. What federations in SQL Azure does is it reduces the consistency of SQL Server a little bit. So we still have locking and we still have transactions, but the transactions only occur within shards, or actually, as we'll see later, the transactions only really occur within an atomic unit. We'll get to the definition of atomic unit soon. So basically, it's not NoSQL. It's still SQL Server, it's just a little bit NoSQL-ish. So federations allows us to do massive scale out of SQL Azure databases to shard. It reduces the consistency model, so it means that our consistency is only really within an atomic unit, so at a lower level. It also gives us a whole bunch more local resources like TempDB and CPU and memory. I'm going to define some of the terms, so we have to define terms. This is definition of terms. You start with a SQL Azure database that hosts federations, and this is referred to as the federation root. So on this slide here, it's a little bit small. SalesDB is a SQL Azure database. We just create it like normal, and then inside that we can create federations. So the fact that we use the create federation command to make a federation inside that SQL Azure database makes it a federation root. One federation root, I'm going to get to that in a second. We can have multiple federations. And then within the federation, there are other SQL Azure databases that are called federation members. So there's one or more other SQL Azure databases that are members of the federation. So we're just defining terms, so I'll keep spinning through this pretty quickly. Now the next really important concept is the concept of the atomic unit. When you make a federation, you define a distribution key. So say this is a federation about customer federation, a federation about customers. You might use the customer ID as the federation distribution key. Now, inside the federation, we can have, say we have a customer table and an order table and an order detail table. That's sort of fairly common. What happens is that we need to put the federation distribution key on each of these federated tables. So customer ID, if that's the federation distribution key, is going to be on customer table, which is obvious, on the orders table, which it probably would be, also on the order detail table. And then all of the rows and all of the tables, all of the rows and all of the federated tables that contain the same federation distribution key, the same value for customer ID 1, 2, 3, 4, they form a single atomic unit. And the atomic unit is the only guaranteed, is really the only ACID part of this federated database. I mean, actually, it could be bigger than that, but from our point of view, the only thing that we know that always stays together is the atomic unit. So an atomic unit is basically a whole bunch of rows in various tables that have the same federation, the same instance of a federation distribution key, customer 1, 2, 3, 4. Okay, I'm going to go over this later, but I'll try and make that clear. And this is just the same thing yet again, but we might as well look at it with a different diagram. So a SQL Azure database, which hosts federations, is a federation root. It can host several federations or many federations. Sadly, they can't be nested. Sadly, would you want to nest them? I don't know. But you can't nest them. So a federation can't contain other federations. You have a root, it can have many federations. Now, the federation is really just an object in the federation root database, but it references federation members. Federation members are real SQL Azure databases. So each federation can have many federation members, which are databases. Inside each of those federation members, you can have one or more atomic units. An atomic unit is basically a collection of rows in federated tables. Almost time for a demo. That's right. So there are three types of tables in, that we consider in federation. There are global tables that live in the federation root. The problem with there's a problem, not really, I mean, but it's singular. Any global, so you can put anything you want, like data that has to do with the whole operation would go in the federation root in global tables. You don't necessarily have to have any tables in the federation root, and I can imagine building applications that had none. The problem with the global tables is that it's not really scale out. There's only one of them, so there's, when you go to update it, there's one lock, etc. The other kinds of tables that we have are reference tables. So a reference table of reference data, and when you split, when we split one federation member into more than one, the reference tables are copied into each federation member. So reference data is copied into each federation member, and then federated tables are tables that have, when we declare them, you'll see that we say federated on. And those tables include the federation distribution key, and those tables are split. The rows from those tables, the tables are duplicated, and the rows from those tables are split based on their key into different federation members. Okay, so the difference between federated tables and reference tables, reference tables are reference tables. Now, you can do joins, you can join federated data and reference data, that works okay. You can't really join to global tables because we don't have, you can use the data, but you can't do joins on them. So there are two really cool things in federations, and the first one is the ability to split data. So we can say we've created a federation. We can say alter federation split. You choose a value to split at, and so we're saying here split at whatever ID 7500. Now, which one is which way? Oh yeah, 7500 goes right. What happens is that we take the data, the existing data in the federation member that contains ID 7500, and we create two new SQL Azure databases, and all the reference data is copied into each one, and then anything below the ID that we specified goes into the left one. Anything above, that one or above goes into the right one. Which, okay, you can do that with there are other systems that allow you to do this. The beauty of this is that you can do this while it's online. So, and that's actually the real, the really cool thing about this is that this can be a system that is online that we're using, and we're making changes and we're pumping data into it, and then we can say split, and the split operation is going to happen in the background. But we can still access and update the database that we're splitting. And then eventually, when the split operation is complete, the old database will go offline and the two new databases will come online. Now, at that point in time, any applications that were talking to the old database are going to be disconnected. But if you write code for SQL Azure, you know that in SQL Azure, we're supposed to allow for disconnections at any time, because there are many reasons why, when you're talking to SQL Azure, that your connection can be, you can be disconnected. I mean, for example, the network can go down, or sometimes databases are moved for performance reasons. So, it's just a normal thing in SQL Azure that disconnections happen, we react to them. So yeah, the cool thing about this is that we can keep updating the database while the split operation is occurring. It's really time to have a look at some of this in. All right. Some bad news first. So in SQL Azure Federations version 1, which is sometime in Q4 of 2011, the only alter federation command that's supported is the first one, which is a single split. So split one database into two. At some point after that, so SQL Azure is an agile project, so they do drops every n months. Probably 4 months after that, we'll get merged. So in the first release, you're going to be able to split, but you're not going to be able to merge. And they talked to the customers and they said, that's cool, it's okay. We just need to be able to scale out. We don't need to be able to scale back. It's not quite so important. We'd like to, but it doesn't have to be in version 1. So when they release it, you'll be able to split, but you won't be able to merge. And then pretty soon afterwards, you'll be able to merge. And then the other two, multiple split and multiple merge, are actually just performance enhancements, because it's better to do 10 splits at a time than to do 2, 4, 8. Right? It's just more efficient, less copying of data around. Good. Let's have a look at this. Oops. So here we have, I'm going to use a mouse. Can't really see that very well. Let's Control 1. Okay, so we're connected now to the Azure Federation CTP server in Redmond. Is there anything interesting you guys can see about that? Anybody want to? No? It goes to 11 again? Yeah. If you have a look at the version number of SQL Server, it's Denali. So this is, what is that? Is it SQL Server 2011, 2012? I don't know, whatever it is. But yeah, basically, this is running on the next version of SQL Server, and SQL Azure may well be running on that at some time in the future. We said this is released in Q4 2011, so yeah, that's in a slide. So we're connected to their server in Redmond, and what I'm going to do is create a federation root. So we are connected to master, okay. So I'm going to make myself I'm just making a SQL Azure database. I'm doing a create database. It's just the standard create database, and we've got one. So there's nothing different about that. Okay, so this is where we go a little bit different, is we create a federation. We create a federation, I'm calling it tick federation. It's going to use an integer distribution key called IID, and we'll just take the default size. Except it says on MarketDB. So I can do this once. Yes. All right, switch to MarketDB and then create the federation. Okay. So now we have our federation root, MarketDB, and we also have this system database. There's another database there. When you create a federation, it automatically creates one federation member for you. So that system blah-de-blah-de-blah, that's a federation member. Okay. And now what I'm going to do is I'll just create a couple of tables. So I'm going to use the use federation command, which points me at a federation. It's kind of interesting, in SQL Azure there is no, the use database command doesn't work, but if we execute this, see we're set to MarketDB? If I execute the use federation command, it sets us to that system database, which is kind of interesting. So it does what a use database would do, but not. And I'm going to create a couple of tables. Firstly, I'm going to create a federation table. So it's just a standard table. The only real difference is it says federated on. So we've got this keyword federated on, and that says, when we say that, it tells SQL Azure that this is going to be a federated table, and we're in a particular federation at the moment because we issued the use federation command. This is going to, and then we have to say which column in this table is the federation key, and it's going to be instrument ID. So I'll just create that table. And then we're going to create a reference table. Really, a reference table is just, we're in, if you can see where we are at the moment, we're in the federation member and we're creating a reference table. There's no special keyword to define a reference table. Okay. And then I'm going to load some data up and we'll do some more slides and then so we just created a federation. Now, so what are we doing all this for, or why would we want to do this? The reason that we really want to do it is so that we can use this use federation command. So, basically, when we need to program against the federation, firstly we connect to the root database. We always connect to the root database. We're not going to connect to system unique identifier. That's crazy, right? We make connection strings, and the connection strings go to the federation root database, and then we use a use federation command. And what the use federation command does is it routes, after the use federation command, the client is going to route all of the requests for particular data to a particular shard. So what the use federation command allows us to do is data-dependent routing of commands. So this command goes to that database because it has this key. I guess we don't really need to say much more about it. But when we have a look at the samples, you'll see what that actually means. That's actually a pretty cool thing. There is another important feature of use federation, which is filtering. When filtering is on, so when I say use federation name, and I put in a distribution key, so in here we're saying customer ID 55, filtering is on. After this, any commands that I issue are only going to affect the rows in the federated tables that have this ID. So this is really how it's safe to use. Sorry. Right. Better get a drink of water. Okay. Yeah. Right. We're back. So, one of the big problems with multi-tenant systems. So, you don't want to. If you've got customers and you want to put customers in SQL Azure, but you don't want to pay for a SQL Azure database for each customer, then you want to put multiple customers in one, but you don't want to get them mixed up. And basically, if your code does connect to federation root, use federation filtering on, then whatever commands your code does after that is only going to see the data and be able to update the data for that particular customer. So this is really the killer feature here in terms of multi-tenancy anyway. So what we're going to be able to do is we're going to be able to put lots and lots of our customers into a single SQL Azure database and then safely code against it. And that's what filtering on does. Filtering off is really used for filtering off is used for maintenance operations. So when you say connect to use federation, connect to federation root, use federation, we give it a customer ID. Basically, that connects us to the SQL Azure database that contains that atomic unit. So customer ID 155 defines an atomic unit. So it connects us to the whole database, and really we use that to do things like update reference data or I'll make changes to schemas and things. So filtering on is really what we use when we're coding against federations, and filtering off is for maintenance operations. Let's have a look at the split. Yep, I was right there. Okay. Back to here. So what I've done is we've got this situation where we have a federation root and we have a federation. It has one federation member. In that member, we have a bunch of instruments, right, which are actually stock market instruments, and a bunch of ticks, which are actually stock market ticks. What I'm going to do is I'll do the use federation command, and this is with filtering off. We just talked about that. So connect to the federation that contains ID 1, don't filter, and tell me how many instruments there are and how many ticks there are. And if you remember, the instruments table is a reference table, and the ticks table is a federated table. So let's do this, and then zoom it in. So there are 133 instruments and 1,000 ticks in that in that federation member. Now, there's only one federation member, and I loaded 1,000 ticks into it just before, so that'd be about right. So we're going to do exactly the same thing. The only difference is that in this case, I'm saying filtering on. So use federation name, where we have that atomic unit, but filtering on, which means that we're only going to see things that belong to that particular atomic unit. So there's a big difference here. We still have 133 rows in the instrument table, but as far as our T-SQL knows, count star from ticks, there are only 4 ticks in this database because it's automatically being filtered. We filtered on the federation distribution key. And, that might not seem like such a huge thing, but it's pretty cool if you wanted to build a multi-tenant system. Right? One database, multiple tenants, it works pretty well. There are reasons why I'd like to do that in normal SQL. Okay. Another use command that actually works in federations is use federation root. So at the moment you can see we're set to this system database, to this federation member. I can use federation root and go back there. Now I'm going to do a split operation. So I'm going to split this at ID 100. The command completed, but it's still working. So at the moment, whatever database I forget which, I don't remember GUIDs. Whichever database we were connected to is still there. And if there were applications using it, they'd still be referencing it. 2 more databases have been created, and they're getting data copied to them. Actually, by now, that will be finished. Right? So it's done. So now we have 1 federation root and 2 federation members because we did a split. And now we're going to connect to the first federation member, whatever that is. We could do a show DB name. It doesn't really matter. So I'm going to connect to the first one with filtering off. Right? So you remember filtering off lets us see everything in the federation, whether or not it's in that atomic unit. Yep, I just stuffed that up somehow. Oh yeah, I went there. Okay. So you can see, well, you probably can't yet, but if we go down here, you can see that in the first federation member, we have 133 rows in that reference table and 837 rows in the the federated table. And then I'm going to do the same query, but I'm going to say pick the federation member that has ID 101 in it. And since we've got filtering off, it doesn't really matter. We're not just concerned with 101, we're going to see everything. And you can see that we still have 133 instruments because it's a reference table that was copied into both databases, but we only have 163 of the 1,000 ticks that we used to have. Okay. Now, okay, I'm going to do that demo in a second. Other things about federations. In federated databases, you're not allowed to have any identity columns. I guess, you can sort of think of ways. Okay. A bit of cough. Okay. That's because I went to New Zealand, right? And there are no identity columns in federated databases. And it kind of makes sense because identity is really a database level concept, right? So your identity is basically a database level idea. And the thing about these federated databases is that there's more or less of them. The actual databases appear and disappear, not really randomly, but they just come and they go. So you can sort of think of ways you could implement identity, but it would be pretty hard, and any way do you really want it? Right. Yeah, okay, some people want identity. So, if you need something like an identity column, the recommendation is to use unique identifiers instead. Always an argument, unique identifiers versus identity, DBAs versus developers. So the developers won. Also, databases that you federate are somewhat denormalized. There's a degree of denormalization that you have to do. The federation key has to be in each federated table. So if you have the example of, we have the classic, customer has orders, orders has order details. What you would normally do is the customer ID would be in the customer table. There'd be a foreign key in the orders table to customer, all good so far. But all order detail needs is a foreign key to the order table, to the order ID. If we want to put this into an atomic unit, if we want to put it into a federation, we have to put the customer ID in the order detail table as well. So the degree of denormalization here is that the key that we're using as the distribution key has to be in all the federated tables. Also, any unique or clustered index on a federated table has to contain the federated column, which kind of makes sense because the indexes can only work if the atomic units key is in the unique in the index. And there are no distributed transactions in SQL Azure anyway, but in this case, even more we don't have distributed transactions. It would be possible to implement distributed transactions, hard but possible, and they might do it. But the thing is, when we're thinking about building things with this, we're thinking about thousands of databases. So if you can imagine how complicated it is to put together a distributed transaction, 3 databases is quite hard. 1,000 is like, that would be probably really slow. So basically, we design our applications so that we have transactions, but transactions really they don't go any further than the atomic unit, and that's the way you have to think of it. We transactionalize, but we only transactionalize around the atomic unit, around the customer, around the tenant, around whatever it is that we're using as the distribution key for this federation. So, we're not supposed to have code here, but we have code, right? So first, let's have a look at, we're going to create a view that we're going to use in some code. And what this view does is it uses one of the, one or two, sysdot federations. It uses a couple of new system views, sysdot federations and federation member distributions. And when we do this, you'll see what that does. So what it does is it just gives us a report of, we're connected to the master DB, connected to the federation root. And what we're doing here is we're saying, okay, for the tick federation, what are the federation members and what are their ranges? So we found out that there's 2. One of them is from, was it negative? Yeah, it is. To 100. And the other one is from 100 to null is basically max, right, in here. Where that's going to be useful is we're going to do some code now. Not that piece of code. Yeah, this piece of code. It's a very simple piece of code. We've got an entity framework model, and that model, it contains just those 2 tables that we've been looking at, the reference table, instruments, and ticks, the federated table. So that's what's in fed context. It's an entity framework model with 2 tables in it. We're going to open the connection to that, and then we're going to issue the use federation command. So entity framework doesn't support SQL Azure federations, but it does support SQL commands. So at some stage in the future, they might support SQL Azure federations in entity framework, but it doesn't really matter because we can just issue a command. We can issue a command against the store. In this case, we're gonna set our atomic unit to 1 and say filtering on, and then we're going to do console write line. Now, I forgot something there, didn't I? Because we haven't seen that in. I missed something in here. So we split. Oh no, that's filtering off. I didn't do it with filtering on. Okay, seems fair. In fact, maybe we should do that with filtering on. Let's do that with filtering on. So let's just go filtering on in here. So what I'm going to do is I'm going to say point to the federation that contains the ticks with instrument 1 filtered, and give me a count of, I really only want ticks, but it doesn't matter. See that? So you can see that when we're filtered, we only have 4 ticks that have ID 1, okay, in T-SQL. So what we're going to do here is pretty much exactly the same thing, but through Entity Framework. And I guess I can just run it. And that's just getting the IDs of any ticks that are in this atomic unit. So what we just did was we wrote some code that safely, so we have like a multi-tenant system. We have a database with lots of different stuff in it. In that federation member, there are 637 rows. We used that use federation command. We said filter on this distribution key, on this instance of a distribution key, and then we just did a select, basically. It would have turned into a select against it. And we got back only the members of that thing. And we could change those and save them. Basically, we can program safely against a database that has multiple tenants, specifying the tenant ID that we want to use. And here's another slightly more interesting example. So what this piece of code does is it uses that view that we just built. So you remember that back here we just built a view, and that view gets the ranges of any federations that the ranges of any federation members we have, and passes them back for us. So what this is, again, an entity framework model that just has that view in it. What we're going to do here is we're going to go and get each of the federation members. So whatever federation member databases we have in this federation, we're going to go and get those. And then in parallel, we're going to call get ticks and pass the low range of the federation, because the low range is the one that's guaranteed to be in it. Remember that, you probably don't remember, but it says the range is low to high. Strangely, the high one is not in that federation. The high one is in the next federation, because then the next one, so it was negative something to 100, and then 100 to null. The high one is in the next federation. So we use the low range, pass that to get ticks. That's going to use a different entity model, which again is pointing to those 2 tables, or we don't really need both tables, but it has a tick table in it. We're going to issue the use federation command, passing in the low range that we got from that query on the system tables. And then we're going to return the ticks. Then we're going to count them up, and we're going to write them out to the console. This is very exciting programming. Okay, so we counted 1,000. What's interesting about that is that we just did a fan-out query over. We used the system views in the federation root database in order for us to implement a fan-out query over all of the members of the federation. So we could have had, 1,000. We could have had 1,000 databases at federation, and we can query across all of them at the same time if we want to. So really, there's not much more. I'm just going to wrap it up now. So SQL Azure Federations is about sharding. And you can shard, there are many ways. What we want to do sharding, if we need to scale our data tier out, right? Sharding is the way that we want to go. There are a lot of different ways that we can do sharding. SQL Azure is really good for sharding because it has huge scale. So you can always create more SQL Azure databases and use them and move data into them. So SQL Azure works as a solution for sharding. What Federations does is allows you to do that, but gives you controls that are in the engine and in the language that allow you to control the scale out and the scale back in. Not many people talk about scale in. So with Federations, you can scale in as well as scale out, right? It allows you to do that without having to build a whole lot of code of your own to control that. So there's some salesy stuff here, but basically, well, it is important that you only pay for what you use. So if at some point you need 10 databases, you have 10 databases, you can go up to 100 for a couple of days, go back down to 10 again, and you can do that using split and merge when merge eventually gets delivered. It makes it easier to do multi-tenancy. Improving the developer experience is really about the multi-tenancy thing. It's about the use federation command and the fact that I can just put in the range that I need, and then that means that my code is only going to deal with the atomic unit that I specified, so I don't have to code for that. And management experience is about that. There are commands to do this sort of thing. So basically, you can do sharding with SQL Azure. Federations make sharding easier in SQL Azure. And one day, they'll deliver, so these are things that they're talking about doing after V1, fan-out queries. So, that fan-out query that we did is not really part of, basically that was a little bit, wasn't really cheating, but we used some of the system views in order to allow a fan-out query to work. And there are some more sophisticated ways that we could do that, but yeah. So, but support, native support for fan-out queries is going to come along at some point. Schema versioning and management, that's interesting. The trouble is that each of those Federation members is an independent SQL Azure database and actually can have its schema is independent. After it's split, we could have split it and then changed the schema of those, and because you can actually, if you get that system-GUID thing, you can actually connect up to the database and do stuff to it, like change its schema. That's not very good. You probably shouldn't do that, but yeah. So what happens if what if we have 1,000 of these databases and we decide that we want to add a column to a federated table? So that's something that isn't going to be in V1. But they're going to be working on. And the other thing is that this is all very, very fun and stuff, but when I'm sitting on a train with no connection to the internet, I can't play with this stuff because you can't run SQL Azure Federations on your local machine. So what they're planning to do is to provide a developer version of SQL Azure. So Federations is obviously not really going to be in SQL Server, but a developer version that you can run on your own machine, so developers can do this without being connected to Azure itself. Okay, you'll be able to, if you want this address, I might just leave this up because there's nothing more that I've got to say. If you want to have if you want to use the CTP, if you go to Sihan's blog that you can see up there, you can fill out the survey questions. That's quite amusing. Has anybody actually looked at this, the survey questions? No, amazingly popular. When I looked at the survey, it's like the most complicated survey I've ever seen in my entire life. It's like you need to know so much in order to fill out those survey questions, or maybe they've made it easier. But anyway, go and have a look. If you want to try this program out, you can you can go to the survey link and yeah, join up with the program. I'm just going to check that what other things we've got here. Actually, I can check it over here. All right, very good. No, that's it. All we've got. I'll just leave this slide up, but any questions? You could have been asking questions in between time. Anybody want to make it? Yeah, sure. Yeah. Not at the moment, no. Huh? Oh, yeah, sorry. Repeat the question, yeah. So if you change the federation route, will it change all the federation members? No. And that's one of those things that they said, when they say future schema versioning blah-de-blah, that means, yeah, one day, but at the moment it doesn't. So basically what you have to do at the moment is you get it right first time, and then you put it out there, and you can change it. It's all right. It is possible to change it, but we'd have to write some code. Like, so if I already deployed one, and I have a couple of hundred federation members out there, what I would have to do is go to the federation route, do the query on the sys tables, and then apply the schema change commands, go for each sort of thing and apply it to all of them. So, yeah, no, in version 1, nothing as sophisticated as that. Yeah. Backpack, yeah, but backpack was just, yeah. Why do I care about backpacks? He's talking about backup, sorry, it's just backup and restore. Yeah. Anyway, sorry.
Moving out one single federation into its own federated platform rather than array, just one.
No, I don't understand.
Your
Yeah.
federation ID 100 is
Yeah.
split, so it's going to create two separate databases.
Yeah.
But if you just want to grab one particular federation and say, I want to put that in my database,
Yeah.
anything else, not a split, it's just like this specific federation is going that one over here.
Okay, so the question is, what if I just wanted, so if I have a range of, and it's a good question actually, so say if I have 100 customers, one big one, one big one, 10 medium-sized ones and 99 small ones. No, it doesn't make a lot of sense, but anyway, you know what I mean, 89 small ones. What I might want to do is put 89 of them down here and sort of spread these ones, 5 per database, and have the big guy in a database all by himself. No, there's no real automated way of doing that. You could sit there and go, you could invent a federation key that would let you do it, and give the big guy 99 or something, or 9999, and then use that. So no, basically there's no support for saying pick this one and put it here. Although it's a very good idea, and I'll take that up. I hadn't thought of it actually. That's really useful because we're talking about multi-tenancy and splitting things around. Yeah.
Is that
Merge at, yeah, split at and merge at are really just, they're still range based. We're talking about saying, I want that guy to go in this particular one. Right. Yeah. Okay. So yeah, there's not really a way I can get back to you on that, but yeah, I haven't heard of any way of doing that, but it makes sense that you want to. Yeah. Yeah. No, you'd use a GUID. So a unique identifier just as instead of identity, yeah, you just use a GUID. In the actual stuff that I've done, which obviously there's no production, so this is all just CTP. So they were quite outraged at how much I uploaded, a day's worth of stock market data to their CTP, and when I told them, they went, "You put how much data up there? Oh no!" Anyway, what's the point of that? Yeah. So generally, in the stuff that we're working with, we actually have the IDs that we don't use identity because the ID is already set. So we would have pre-processed information, given it a unique identifier, a unique key, and uploaded it into this stuff, because we're doing sort of heavy-duty queries across a lot of them. So you don't, identity sort of gets, there are ways around not having identity without using unique identifiers. So we could have assigned the identity somewhere else and then uploaded it, yeah. Okay, any more questions? Yeah? Yeah, I didn't say the 4 things that you can do ranges on are int, big int, unique identifier, and var binary up to 900. So yeah, you can distribute on a unique identifier, and I haven't really gone into that, but there are ways that they group together in a particular way. Maybe you know more. So sorry, the question was, can you distribute on a unique identifier as a key? And yeah, you can. Yeah. Any more? Okay. All right. Are we early? Mind-bogglingly early? No? 15 minutes? Well, that's all right. I mean, as long as, basically what you're supposed to get out of this is what this thing is and how it works. And if that's what you got out of it, then it doesn't really matter if we're here for however long. So, anything else you want to know? All right, good. Let's get out early then. Get out while the getting's good.